Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In today's lesson, we're going to be taking a look at functions, this time revisiting parameters and some of the qualifiers that we can put on to write safer code. So with that said, let's go ahead and jump into the D programming language website, and we're going to be looking at the functions language reference page here. And let's go ahead and navigate ourselves over to functions, which is down over here. And what I'm going to be looking at here is, in particular, scope. So scope itself is one of these terms that we've seen or will see again in this series. Scope we've seen, for instance, can be used for RAII in the instance that you want to, well, have some function maybe called before you exit a particular scope. But this particular scope also has to deal with your sort of scoping rules that you learn when you're first learning how to program in some curly brace language, right? This basic idea that if I create some variable here, int x equals 0, that its liveness, or where its scope is between these curly braces. So again, that's the idea of scope. But now we're going to see how that applies to parameter functions and can help us write safer code. So let's go ahead and look over at some of the different scope keywords. And specifically, I'm going to be looking at scope parameters today. So let's go ahead and click on that here. And this is what I want to look at. This idea that we can qualify a function with scope. And this has to do with setting up what's called an escape analysis, which is performed on safe functions. So let's go ahead and think about this here with our little example. So let's go ahead and say that instead of creating this type here, let's go ahead and do something a little bit more interesting with our experiment. I create a pointer here, p, and I assign it to something that's the address of a, say, global variable. Okay. Now, again, if I go ahead and have this function here, or something within this scope, this is still sort of interesting or maybe okay, right? It's still this local variable that's sort of temporarily holding on to something that has a larger scope. But let's go ahead and flip around the problem here. Let's go ahead and this time say that I have some global variable. So let's go ahead and clean this up here. So just follow along with me here. Let's go ahead and create some global. I'll have my main function here. And let's have some function in this case here. I'll just call it func for short. And I create some local variable here. And I assign global to the address of this local variable. Okay. So again, I'll write this out in neater code here, but where I want to draw your attention to is right here, where things are kind of interesting. I've got this local variable, its scope is right here, but I've got this global variable that's saying, well, take the address of this thing that's local, and remember my global variable, I have access to it, well, everywhere in my main function or elsewhere here. Okay, so that's the key issue here that we're dealing with when we talk about scope and the parameters of our scoped function here. So anyways, let's go ahead and take a look at scope parameters. And we can see from this example here, and this special escape analysis, which you haven't maybe have heard of in other languages or maybe not, is the basic idea that, yeah, if I have these global variables here, and I have a bunch of safe functions, so again, safe, make this a little bit bigger for you, marks all these functions as safe. And we've looked at safe, trusted, and system code, right? System's the default. Trusted lets you call into safe code if you know what you're doing, and sort of the bridge. And then safe is, well, we're trying to prevent some errors. So these are all sort of safe functions here. And the basic idea is, yeah, if I have some parameter here, q, which is marked with scope, well, if I assign a global variable to it, that's sort of a way to cheat and escape the scope here, right? The scope of q is just supposed to be for this function. So qualifying our parameters with scope here means that it shouldn't escape this function in any way. And that could include a global variable. So let's take a look at some of these things. I think this is kind of interesting, and this is sort of some of the future direction for the safety in the D programming language. That's going to be available here, but I've cooked up an example for us here, and I'll make it a little bit bigger, and let's go ahead and make sure it fits on the screen here. And let me kind of walk you through this code here. Okay, so again, I've got a global variable here. Now, let's actually just make things really simple here. Let's start with line 14 and 16 here. So here's a function that returns, or rather that takes in by value a parameter here, var. Takes in by value var. And this is a value type, okay, which is a value type. And basically, we don't really have to worry about this too much here, okay? It returns a variable here. That's just a copy of this thing here, okay? So what I'm going to show you here on the documentation, and let's kind of skip around a little bit here. There's a nice page on the documentation here talking about the parameter storage classes. We'll look at all these. We've got to look at in, out later. We've looked at ref in this series. We'll look at return later, and of course we have lazy. But scope here says the parameter, again, must not escape the function call, example, by being assigned to a global variable, but it's ignored for any parameter that is not a reference type. Okay, so scope doesn't really apply here. Okay, so what I'm going to go ahead and do here is mark this as scope, and I'll even make this a safe function here. Okay, and let's go ahead and, well, let's just comment out all of my code here, so you don't really need to worry about anything interesting happening here. Let's go ahead and pop this guy in here. And let's go ahead and compile this. Okay, now I'm going to compile this with dip 1000, which is the sort of one of the latest standards for the D language. You don't necessarily have to do this. Now let's see, I'm getting a segmentation fault here. Oh, that's because my global variable. Let's initialize that here. Okay, let's not have any wild errors here. Now I can print this out. But the point is, the compiler is not finding anything wrong with this code here. Okay, even though it's safe, right? This is just a value here. Okay, meaning that we pass by copy and nothing, really weird to worry about here as far as side effects, right? I can return the value. That's just going to return a copy for this int, so no problem. Okay, so let me just go ahead and annotate this. This is totally fine. Okay, now let's look at something a little bit more interesting here. Okay, so let's bring in the rest of our code. And what I'm going to go ahead and do is uncomment this here. And I've set up a reference type for us here. Okay, so I've got a global variable here. One global. Be careful, it has global scope. Okay, and that's the issue with global variables, right? They're available everywhere. So, it effectively can be tricky or wreak havoc on your program by allowing you to share data that you maybe didn't intend to share. Okay, and that's going to become really important later on in D programming language lessons when we get into concurrency. Again, stay subscribed for that. But again, the idea here of this global variable is going to be a little bit of a troublemaker. Now, the key here too is I've made this reference type. So this is just a class, right? Classes are always reference types. And I'm just wrapping an integer value here. Again, just to make it a little bit more interesting, right? So anything that's a reference type, like a class, is something that we care about that could escape. Okay, so now let's actually use this in a function here. So I've got a function here that's going to return a variable of this ref type, and it's going to take in that ref type as well. And it's also going to set a global equal to this variable here that we're passing in. Okay, effectively giving this variable global scope because we'll be pointing into it. Okay, so let's go ahead and just take a look at this here. Now let's compress this just a little bit so you can see, what's going on in every line of this code here. Let's go ahead and, I'm just going to go ahead and compress everything so you can see it all. Let's go ahead and compile this here. And this works fine, okay? It doesn't complain to us in any sort of way here. And what I'm doing is setting up my global variable by allocating it, right? Any class, we have to allocate memory. Then I just give it some default value, 8888, that's fine. Then I create a new ref type here. That's what I'm gonna pass into this function here, R. It's gonna come in here, and since it's passed by reference, the reference type, right? I can modify it. So I'm setting my global equal to this var here, which I've initialized as 0, and then writing out the value. So R is unchanged at 0, but our global is now 0, right? They're sharing, okay? So again, I'll run this, no problem. Now, if you've been following this series, you might have learned that we've learned about pure functions. Okay, so let's go ahead and try to run this now. And this does give an error here. This says pure function cannot access mutable static data global. Okay, so again, pure functions are great because what they do is they say, well, anything that's coming in shouldn't be modified effectively, right? And I am modifying it, right? I've got two different scopes here. So pure is a great tool for us to try to write functions as if possible. But again, sometimes you need to pass in, reference types, for instance. Let's get rid of this here and try with pure. That's still okay. If we don't have pure, let's talk about scope here. So what I'm going to go ahead and do here is let's go ahead and annotate scope in front of this variable. And let's go ahead and give it a run here. And now I'm getting an error here because it's saying, well, this scope parameter var may not be returned. Okay. So that kind of tells you what scope is about here. It's saying when I pass in a parameter, and we've done this before, right? This is just like this function here, where the scope is only between these curly braces. The same thing here, except I'm just really enforcing it strongly. And how am I escaping in this case? Well, with this return value, okay? I'll just annotate this as oops, in escape, okay? Because I'm returning this somewhere else. Why is this particularly dangerous? Well, maybe I'm returning this and assigning it to a global somewhere else in this function, right? Because this is returning a ref type. So somewhere else, right, I could be in this function, like at line 24, going, I'm just going to assign the global like this, okay? So this could be dangerous here, okay? So that's the issue. Okay, so I'll go ahead and erase that here. Oops, and escape. Okay. So again, that's going to cause a problem here. But let's say again that, we don't, return something dangerous here. Let's just return a null value here. Okay. Let's try to run it. Still okay. Okay. So can we make this safer in some way? Well, I'm still doing this dangerous thing here, right? Our global variable, it's still being modified here, okay, with this scope param function that I'm calling here. So let's mark our function at safe, okay, and it's going to perform this additional analysis here. And now it's going to tell us, again, scope variable var assigned to global variable, well, named global, okay? And that is a possible escape, okay? So escape. Okay, so these are some of the things that we have to kind of look out for, but scope's going to help us out. Now, the other thing to do here, let's go ahead and say this is safe and a pure function, which again, a pure function means that, we don't have any mutation. Scope, and the difference between this is that we're just looking at, the parameters here, right? There could be some other, mutation going on if I don't have pure, for instance, like maybe, if I had another global variable or something, like let's go ahead and say int, global 2 or something, I could be doing something here with global 2 equals, 7 or something. Again, this is a problem with the scope here, right? We catch that. And let me go ahead and just comment that out here. So no problems here. But again, I just want to show you again what the issue is with pure, or why this is good. Pure won't let us, access outside, mutable state. Okay, just so you see the difference here. Pure is like anything accessing outside state, and scope is just for the parameters, kind of taking a look at the scope here and making sure we don't modify things. Okay, so again, if you can write functions that are pure and with scope, that's great. That's, safe functions that don't mutate. They're sort of in this category, we would say, it's like strongly pure, not escaping. Inputs that come in are going to give you inputs that come out and not create other side effects in your program. Okay, so I know that's a little bit of a long lesson. It could be a little bit confusing, but just remember, scope on a parameter limits you to these curly braces, and it performs this escape analysis to make sure that you can't accidentally escape here. Now this function, what it's actually doing, nothing really useful here. I'm just trying to demonstrate that, again, what the scope keyword is when attached to a function parameter. Alrighty, folks, so I hope that makes sense. I think the D-Language website has some nice documentation. And again, these are some things that are coming, potentially with this new DIP 1000 update. If you've got a latest version of D, you can try running it. If I get rid of this here, and I still run it, now the pure function's complaining. So let's get rid of that here for a moment. And leave that in. Right, you're going to get some other errors about like deprecation and so on. But I would otherwise recommend to start playing around with this scope here, because, it's probably something that's going to be coming. It is a work in progress feature as of now of this recording of the video, but I think it is something that's going to become more powerful and, again, help you write safer code. All right, folks, so with that said, feel free to check out my lessons here and other courses, and you can track your progress if you're going through the D programming language series here, so you can see where you're at. All right, folks, if you have other questions or comments, feel free to engage in the discussion. I'll look forward to hearing your thoughts there if you think this is a cool idea. And again, there's some neat introspection things that D does, for instance, with like auto and templates to infer some of these properties, so you don't always have to specify them. But where I think these things are useful is if you're building a data structure or a library, for instance, to know how to handle this and write, as safe as code as possible for other folks to consume. Okay, so again, we're getting into some of the interesting stuff here, and I'll look forward to seeing you in some of the next videos. And with that said, folks, I'll see you next time.